So you love the second lesson on Inferential Statistics, Applied Maths NCERT Class 12. I'm Suman Matthews, online tutor and coach, and we will start with interval estimation here. So if mu lies between A and B, then this is an interval estimate of the population mean mu. To learn about interval estimation, you need to know what is confidence level. So a 95% confidence level means that 95% of the interval contains the true population parameter, and confidence coefficient is 0.95. So confidence coefficient is 0.95 means the confidence level is 95%. Then you have sample statistics and margin of error. And coming to margin of error, if it is predicted that a particular candidate will receive 40% votes and there is a 5% margin of error, then we say that the candidate will receive between 35% and 45% of the votes. And coming to margin of error, in a confidence interval, the range of values above and below the sample statistics is called the margin of error. So you have the sample statistics and margin of error will be below it and above it. Now the interval estimate of the population mean is given by mu equal to x bar plus or minus margin of error, where margin of error is given by z alpha by 2 into sigma by root n, and z alpha by 2 is the z value. So the interval estimate of the population mean mu equal to x bar plus or minus margin of error. Now 1 minus alpha is called the confidence coefficient, and the commonly used confidence levels are you have 90% alpha is 0.1, so alpha by 2 is 0.05, z alpha by 2 is 1.645, 95% confidence level, alpha is 0.05, so alpha by 2 is 0.025, and z alpha by 2 will be 1.960. This is the value of z from the z table. And 99%, the value of alpha is 0.01, alpha by 2 is 0.005, so z alpha by 2 from the z table is 2.576, and it makes sense to memorize these values for z alpha by 2 for 90%, 95% and 99% in case you don't have access to the z table. Now, coming to problems for the following observations: 102.5, 101.7, 103.1, 100.9, 100.5 and 100.2. If the standard deviation is 1.2, what is the interval estimation for the population mean at 95% confidence level? So n is 6 and x bar, if you add everything, you get 610.9 by 6, which is 101.82. So we have calculated n and we have n and x bar. Alpha here is 0.005, so alpha by 2 is 0.0025, and from our table for 0.0025 z alpha by 2 will be 1.96. So 95% confidence level, so it will be 1.96. So margin of error is given by z alpha by 2 sigma by root n. This is the formula for margin of error. So that is 1.96 into the value of sigma is given to be 1.2 by root n is root 6, so you get 0.96, and you have to find the interval estimation. That will be the formula is x bar plus or minus 0.96. That is 101.82 plus or minus margin of error, which is 0.96. So the interval of estimation will be 100.86 and 102.78 between these values. Coming to the next question, if a 95% confidence interval for a population mean is 150 to 60 and sigma is 15, what sample size was used in the study? So again, mu is x bar plus or minus margin of error, and mu is the interval estimate of the population mean. So here 152 is the lower range, it is x bar minus e, and 160 is the upper range, is x bar plus e. So if we add both together, we get 2 equal to 8 or e equal to 4. Now what is z? Alpha is 0.005, so z alpha by 2, as we saw in the previous problem, is 1.96, and margin of error is given by z alpha by 2 into sigma by root n, so that will be, e is 4 here, 4 equal to 1.96 into sigma is, coming to the question, sigma is 15. 15 by root n. So when we simplify, we get root n is 7.35. So n is 7.35 squared, that is 54.02. So n is approximately 54. The interval estimation of the population proportion is given by p equal to p bar plus or minus margin of error, where p bar is the sample proportion and capital P is the population proportion. And here we have interval estimation of the population proportion. Previously we had interval estimation of the population mean. Now we have interval estimation of the population proportion. And here the formula of margin of error is given by z alpha by 2 into square root of p bar into 1 minus p bar by n. So coming to questions, a random sample of 400 individuals provides 100 yes answers. Find the point estimate of this population proportion for yes. The point estimate is the sample proportion. That will be number of yeses by total number. Number of yeses is 100 by 400, so this is 1 by 4. So this is the P bar, the point estimate. And if to find the second part is find the 95% confidence interval for this population proportion. That is given by p bar minus e into p bar plus e. Now again 95%, so z alpha by 2 is what? 1.96. So everywhere we keep using the same value for z alpha by 2 because we have the confidence level as 95%. So E is z alpha by 2 into square root of p bar into 1 minus p bar by n, that is 1.96 into square root of 1 by 4 into 3 by 4 by 400, that is 0.0424. So your confidence interval will be p bar minus e into p bar plus e, that is 0.25. P bar we just saw is 1 by 4, so 0.25 minus 0.0424, 0.25 plus 0.0424, which is 0.2076, 0.2924. So this is the confidence interval, p bar minus e, p bar plus e. Coming to a few MCQ questions, a simple random sample consists of 4 observations, 1, 3, 5, 7. What is the point estimate of the population standard deviation? So point estimate of the population standard deviation is given by sigma is square root of sigma xi minus x bar the whole squared by n minus 1. We had done this in the previous lesson as well, and that is there in the link. So n equal to 4 here, and x bar will be, if you add all the 4 values, 1 plus 3 plus 5 plus 7 by 4, you get 4. And now you substitute this here. So you get square root of 1 minus 4 the whole squared plus 3 minus 4 the whole squared plus 5 minus 4 the whole squared plus 7 minus 4 the whole squared by 3. That is 2.58, and that is option B. So this is the point estimate of the population standard deviation. Coming to the next question, a sample of 50 bulbs is taken at random. Out of 50, we found 15 bulbs are Bajaj, 17 are Philips, and 18 are Surya. What is the point estimate of population proportion for Philips? So that will be total number for Philips, that is 17, by total number, which is 50, so it is 0.34, and that is option B. So it is sample size divided by the total number. One last question. What does the 95% confidence interval mean? The process will capture the true parameter 95% of the time in the long run. We can be 95% confidence that your interval will include the population parameter. You can be 5% confident that your interval will not include the population parameter, and all of the above. Thus you can see the answer is option D. So we have come to the end of this particular lesson on inferential statistics, where we have learned how to calculate the interval estimation for population proportion and population mean. So thank you, and we meet again